Okay, so we'll get started with the main part of the meeting now. So I hope you enjoyed the planetarium show. I thought Greg gave us an absolutely fantastic show, and he really covered the whole aspect of why we're interested in comets, that they're these bits of leftover debris in the solar system that will tell us a lot, can tell us a lot about the origin of our solar system and the origin of ourselves. So one of the theories for why we have oceans of water on the Earth is that water came from the impact of cometary bodies billions of years ago. So in a sense, we're all here because of comets. Greg mentioned Pluto as a dwarf planet. As Comet Section Director, I actually claim Pluto as a giant comet, not a dwarf planet. Because essentially it's a huge ball of frozen ices that, if it came into the inner solar system, would certainly give us a very, very impressive cometary display in the sky. So I'm just going to give a short introduction now, and then we move on to the main speakers of the day. But in the next 15 minutes, just tell you a little bit about what the BAA Comet Section does and how you can observe comets. So I've already shown this animation. This is an animation of the nucleus of Comet 67P, Churyumov-Gerasimenko, and here is a model of it that you can have a look at during the interval. And Helen will be showing some other shape models. So this comet looks a bit like a rubber duck. So when we first saw it, it looked like sort of body of the duck, head of the duck. So we've already heard that comets can come from two places. They can come from this flat plane called the Kuiper Belt, Edgeworth Kuiper Belt in the BAA, because Edgeworth was a BAA member who came up with the idea before Kuiper did. Or they can come from the Oort cloud. And so there are really two sort of families of comets. There are comets that move in the plane of the solar system, so along the ecliptic, as Greg described it in the planetarium. And there are comets that move out of that plane. And so if you look at a normal comet orbit, unlike the planets, which are in almost circular orbits, moving in the plane of the solar system, comets move usually in highly elongated orbits that are inclined to the plane of the solar system. So this is the orbit of the famous comet, the one that's associated very closely with this observatory, Halley's Comet 1P, the first periodic comet. Highly inclined orbit, and even more so, it actually goes around the solar system in the wrong direction. So all the planets go around the sun in this direction. So if you look at the top, they go around in an anti-clockwise direction. Halley goes around the sun in the wrong direction. And so we think all of these long period comets, these comets in inclined orbits, random orbits coming from all directions, come from this spherical shell of comets called the Oort cloud. Now, nobody's directly ever observed the Oort cloud, but we can infer it from the furthest distance these comets come from. And it's huge distances out from the solar system, a large proportion of the way to the nearest stars. So hundreds of thousands of times further away from the sun than we are. So what are comets? So comets are that nucleus, this icy thing at the center of the what's called the coma, or its atmosphere. And comets also have tails. And David Levy said famously once that comets are like cats. They have tails and they do what they want. And that's pretty much how comets are. One of the things that makes them really interesting to observe is you never quite know what you're going to see. You can go to a comet one night and it'll look one way, go to a comet the next night and it'll look completely different. Now this is an example of a comet with what's called an ion or gas tail. So what comes off the nucleus here is gases. Those gases get ionized by sunlight and they get pushed back away from the sun by the solar wind. And the solar wind comes from the sun at a velocity of 400 or so kilometers a second. So what you're seeing here is the effect of solar wind pushing that gas away from the nucleus to form an ion tail. This is an example of a comet that had a very spectacular dust tail. So what comes off the nucleus, in addition to the gases that get ionized, is dust. And that dust is very, very small, low mass. It gets pushed away from the head of the comet, not by the solar wind, but by the pressure of sunlight, solar radiation pressure. And so comets' dust tails are rather different from gas tails. They're not straight, they can be curved because they stay in the plane of the comet's orbit, and they get pushed away from the nucleus and effectively go into little orbits of themselves. And of course, all the dust that comes away from comets has to go somewhere. And eventually it goes into loops around the sun. And as you'll hear from John Mason this afternoon, it's that dust that eventually, if we're in the right place at the right time, hits the Earth's atmosphere and causes meteor streams. So we can sort of thank comets. As I'm increasing, I've already adopted Pluto in my section. I'll also adopt meteors because essentially they're comets too, or the bits that come off comets. Now, one of the slightly unfortunate things there is that the most powerful meteor stream that we have, the Geminids, actually doesn't come from a comet, it comes from an asteroid. But that must mean that that asteroid is really a comet somehow, but we haven't quite worked it out yet. So this is just showing what they look like together. This is a recent comet, which hopefully many of you will have seen a few years ago, actually in the summer of the first lockdown summer, 2020, July. This is a comet called Comet Neowise, and it shows the two tails quite nicely. You've got this broad dust tail here, which is shining by reflected sunlight, and you have the narrow, straight gas tail, which is actually shining by fluorescence. And you can see one of them is blue, the other one is whitish, because essentially that's reflected sunlight. And this was just a gorgeous comet. We don't get comets like this very often. This is probably the best comet that we've seen. So this was in 2020, the best comet that we've seen since Comet Hale-Bopp, certainly in the Northern Hemisphere, Comet Hale-Bopp back in 1997. So when I'm talking about observing comets, these kind of comets that you can see beautifully in the twilight sky and photograph with small instruments or see in binoculars are quite rare things. But we do get a lot of other comets. The kind of comets that we tend to be observing every night, whenever we can, are comets that look like this, helpfully indicated by the two bars there. So magnitude is a measure of brightness. It's kind of a bit like a golf handicap in that it goes the wrong way. So something that's magnitude 2, which is what Comet Neowise was, is a lot brighter than something that was magnitude 18, which is what this comet was. But comets can do interesting things. So you might think, well, why are we really interested in faint comets like this? And one of the reasons is that they can actually go into outburst. So you can be looking at a comet one night and it can be really faint, and then you go to it the next night and it's suddenly become much brighter. Now, this is the comet that our next speaker, Richard Miles, is going to be talking about. This is a comet called 29P, and this is a recent outburst. And what happens, and Richard will go through all of this, is that all of a sudden the comet becomes much brighter, there's material pushed out into its coma, and over the next few nights, you can follow that comet getting bigger and bigger and bigger and brighter. And there was a really good example of that, Comet Holmes, back in, was it 2007, Holmes? I can't remember, but it was that's a more recent outburst, but the really bright outburst of Holmes was 2007, I think. Anyway, that comet went from being really faint, so you couldn't see it with a big telescope, to being bright enough to be visible with the naked eye. Effectively, it looked like a new star in the constellation of Perseus. So if you want to be a comet observer, what can you observe comets with? Well, one of the best things is usually a pair of binoculars, because comets are usually the brighter comets, the ones that come close to naked eye, are normally fairly big, fuzzy things. And so they can be quite difficult to track down in telescopes. But a comet that's maybe of magnitude 6 or 7, which sounds like a fairly easy magnitude to get to, because from a dark sky you can see 6th magnitude stars. But of course a comet is this fuzzy thing spread across a big area. So binoculars are really good because they help you find the comet. They give you a wide field of view. So next time you get a reasonably bright comet, if you've got a pair of binoculars, go out and search for it. You need to know where to look, and the BAA website will normally include finder charts and details of where to look. But binocular is a good way of looking at things. And visual observing is still a really important thing. Fewer and fewer people do visual observing because it's quite difficult to do now with light pollution. But people are doing drawings. This is an example drawing of a comet. And people make estimates of the comet magnitude, and we can make things called light curves, which show how the comet brightness evolved. And Jonathan Shanklin is going to be talking about that just after lunch, talking about how we use the estimates that we make of brightnesses of comets to actually make some inference about how the comet works. So the comets have got tails. You can do other things. You can estimate the length of the tails and the orientation of the tail in the sky. And you can also estimate how fuzzy the comet is, a thing called degree of condensation. And all of this is in that Comet Observing Guide, which, as I said earlier, you can download for free off the BAA website, or there's printed copies there if you want to actually have a hard copy. For brighter comets, you can take images just using normal SLR type cameras. This is one on a driven mount which follows the stars around, but sometimes if the comet's really bright, you don't even need that. And here's an example of why photography is so much easier these days than visual observing. This is an image of a comet, a comet called Virtanen, which is quite a diffuse comet. These are the raw pictures out of the camera, but using image processing techniques, you can effectively subtract away the light pollution. So this is what it looks like. These are the Pleiades here. You can see the nebulosity in the Pleiades, and you can see the comet. The comet's green because it's emitting light at a particular wavelength. But you can see that with imaging, you can actually get much fainter than you can with visual, which is one of the reasons why people tend to use imaging more now than they do visual. For fainter comets, you need a telescope. This is an example of a comet that we had earlier this year. This is a comet called C2022E3ZTF, I think, from memory. It was a reasonably bright comet when it came close to the Earth in January and February this year. It reached about 4th magnitude. And this is a picture of my telescope and a little telescope on the side taking a picture of the comet. So there's the comet up in the sky. This is just taken with a normal camera. And then there were cameras on the back of these telescopes which took pictures like that. And this is from Chelmsford in Essex, which is a pretty light polluted place, but it shows what you can achieve with the appropriate image processing techniques. And this comet was really interesting. We went through the plane of its orbit, and so you get to see its dust tail spread out along the plane of the orbit in front of and behind of the comet. So just a couple of things about recent meetings. We had a really good meeting in Prague last year. It's amazing, it's just over a year ago, to look at how amateurs and professionals can cooperate in cometary astronomy. We had a good bunch of people there. Some of them are actually here today, and Helen will be talking about some of the aspects that came out of this meeting. This was at the Stefanek Observatory in Prague, an absolutely wonderful place. And if you've never been to Prague, it's a great excuse to go there. It's a wonderful city. One of the things that came out of that was a plan to equip some amateurs with special filters that allow them to do more accurate observations of comets. And we have those. This is the filters installed on the back of my telescope. So this is the camera. This is the filter wheel. And those filters are interesting because they allow you to separate the dust and the gas in a comet when you take images. So this image and this image are of the same comet at the same time. One of them's in red light, showing mainly the dust content. One of them's in green light, showing mainly the gas. You can see there a huge difference between those two. So there's lots of opportunities to observe comets, but if you don't have your own telescope, or if you live in a place where it's so light polluted you can't do observations, then these days you can actually go online and you can use remote telescopes. And that's the kind of latest technology where you can actually, from your own home, log into a remote telescope that's maybe in Spain or South America or South Africa or Australia and observe comets there. And that's a really good way of observing comets. And there are lots of different providers that do this. So hopefully you'll find today really interesting. I'll hand over now to our first proper speaker of the day. Before I do that, I'd like to mention that the next main meeting that the BAA have got is actually our autumn meeting, which is in Leicester, Friday 22nd to Sunday 24th of September. Lots of interesting speakers there. There are a few flyers for this meeting around the place. So if you're interested in going to that meeting, please take one. please go to the meeting. If you find today's meeting fun and interesting and enlightening, then you'll find the same for the September meeting. So thank you very much. I'm now going to start the meeting proper with the first talk, which is from Richard Miles. And Richard is going to be talking about a very enigmatic object called 29P Schwarzmann-Wachmann. So Richard, would you like to come up and take the podium? Thank you very much.